Hello everyone. Myself, I'm Ganga Bhavani, Assistant Professor in EC Department of IARE. So today we'll discuss about mathematical modeling of mechanical systems. Okay. So in mechanical systems, basically we have two types. Those are translational mechanical systems and rotational mechanical systems. In translational mechanical systems, we have linear motion. There is motion is in like linear motion, whereas in rotational mechanical systems you have rotational motion. Okay, so first if we consider about translational systems, so translational systems you have three basic elements. Those are called as mass, dashpot and spring. Okay, so symbolically this element is represented by a block either as a mass or dashpot or spring. So these are called as passive linear elements of translational motion, right? So first we shall discuss about mass. What is meant by mass? Mass is a fundamental property of matter, quantifying the amount of substance in an object. Okay, so it is a measure of inertia, meaning that it indicates how much an object resists changes in its motion when a force is applied. Okay, so what does mass indicate is it is just a measure of inertia. Means what does it indicate? It indicates when a force is applied on a body or an object, how much that object resists changes in its motion. That itself is given by mass. So this represents an element which resists the motion due to inertia. Okay. So mathematical equation representing mass is given by Fm equal to mass into acceleration. Fm equal to mass into acceleration. And acceleration is rate of change of velocity. So A you can write it as dv by dt, and velocity is again change in displacement. So v can be written as dx by dt. That is how Fm equal to m into d square x by dt square, where a, v and x denote acceleration, velocity and displacement of the body respectively. So according to Newton's second law of motion, inertia is equal to, this is nothing but this second law of motion, inertia force is equal to mass times the acceleration, that is m into a. So using Newton's second law of motion, equation for mass element can be given as Fm equal to m into a, that is inertia force is equal to mass into acceleration. Translation mass is an inertia element. So a mechanical system without mass does not exist at all. So the same thing, if what does Newton's second law state? If a force F is applied to a mass, and see, suppose this is a mass element, you are applying some force F on this mass. If this object is displaced by displacement equal to x meters, then the relation between force and displacement is given by Newton's law, that is Fm equal to m into a or d square x by dt square, since a is dv by dt and b is dx by dt. Okay, so here F is the applied force, Fm is opposing force due to mass. See, F is the applied force and Fm is the force, opposing force of the object. M is the mass, A is acceleration and X is displacement. Coming to next one, dashpot. So this is an element which opposes motion due to friction. So frictional force is proportional to velocity. As how inertia force Fm is proportional to acceleration, here frictional force is proportional to velocity. Frictional force is proportional to velocity. So this force is also known as damping force. How do you write Fb? That is for dashpot we represent the force as Fb. Fb is proportional to V. Earlier for mass element you have written Fm is proportional to A acceleration. Here Fb is proportional to V. So a proportionality constant is taken as B. B is nothing but frictional coefficient. Okay. So Fb equal to capital B into V, or V is again dx by dt. So is capital B into dx by dt. Right. Where Fb is the opposing force due to friction and B is the frictional coefficient, V is the velocity and X is the displacement. Third element is spring. So the third element which opposes motion is the spring, resulting force of spring. For spring, force is proportional to displacement. So if K is equal to K into X, where K is called as string constant or stiffness of the spring. A translational spring is a mechanical element that can be deformed by an external force such that deformation is directly proportional to force applied to it. So a spring, it's a mechanical element which can be deformed. Deformed in the sense whose shape can be changed by some external force such that the change in shape is directly proportional to force applied to it. You must be seeing in a dead left spring. When we compress it and release it again, moves back to its same position. Okay. So circuit symbols for spring are either this form of inductor or is also represented by resistor. Okay. So this is how a spring looks like. So spring is an element which stores potential energy, and the force associated with spring, it is proportional to displacement. So F is equal to K into X. Here K is called as spring constant. X is displacement. So as we see, for mass we write Fm is proportional to A, and for dashpot Fb is proportional to V, and for spring we write it as Fk is proportional to X. Okay. And this is d square x by dt square, this is dx by dt, and this is simply x. Okay, so mechanical system requires just one differential equation called the equation of motion to describe it. So assume a positive direction of motion, for example to the right. This is assumed positive direction of motion is similar to assuming current direction in electrical loop. So in electrical loop we use direction of current, right? So similarly, in case of translational mechanical systems, direction of motion is taken to be positive. Okay. So what is the procedure to draw the mathematical model of mechanical system? First thing what we do is we draw a free body diagram. Free body diagram means what we write. We just simply represent the object by a block. Okay. And we show all the external forces applied on it as well as opposing forces. Okay. So we represent the free body diagram, all the forces that act on the body either in the direction of motion or opposing to it. So we shall draw a free body diagram indicating all the forces acting on it. Okay, in both the directions. Similarly, next step what we do is we use Newton's law to form a differential equation of motion by assuming the forces and setting the sum equal to 0. So sum up all the forces and we sum up all the forces equal to 0. That is, sum of the applied forces and opposing forces, sum of all these forces should be equal to 0. So finally, assuming 0 initial conditions, we take, after writing equations with forces, that is summing up all the forces to 0, next step what we do is we take Laplace transform of that equation, then we try to find the transfer function. Okay. So first thing is how to determine transfer function of mechanical translational system. First thing, we'll identify the number of nodes in the system, then which are nothing but elements of translational system. That is mass elements or dashboards or springs, what are all the elements present in that system. We'll first identify how many systems are there, how many elements are there. Those we call them as nodes. Okay. Then for each node or for each element in the mechanical system, we'll assign the displacements as x1, x2, x3 and so on. Okay. Then we'll draw a free body diagram. For each element, we draw a free body diagram representing all the forces that act in both the directions for that particular body. Okay. Then after writing all the equations, after writing the equations for all the free body diagram, after writing all the equations, we then obtain the differential equation relating output to input. Okay. Then after that, we take Laplace transform of the differential equation to obtain ratio of output by input, dy of s by whatever it is, whatever output is there, ratio of Laplace transform of output to input, that's what gives us the transfer function. Okay. Laplace transform of x of t is given by x of s. Laplace transform of dx of t by dt with 0 initial conditions, it is given by s into x of s. Similarly, d square x by dt square is given by s square into x of s. So with these basics, we'll see, we'll just take an example, simple example. simple mechanical system, that is translational mechanical system. And for this system, I will let you know how to find the transfer function. Okay. So what are the three elements present in the system? We have a mass element, we have a dashpot denoted by B, and we also have a spring. Okay. So if we write now, let me say I'm applying force in this direction, applied forces in this direction. So what are all the three opposing forces? This is applied force is F. So what are all the three opposing forces? Fm, that is for opposing force due to the mass element, opposing force due to the dashpot, as well as opposing force due to the spring. Okay. So how do we write for force for Fm? Fm is equal to, how do we write? Fm equal to mass into acceleration. Acceleration is d square x by dt square. Okay. Similarly for B, for dashpot, how do you write FB? FB equal to B into V, that is dx by dt. Okay, dx by dt. Similarly for spring, Fk. Fk, how do you write Fk equal to K into X? Okay. Now, sum of all these forces, if you equate them to 0, what do you get? And y of Fx and Fy. Okay. So F is equal to Fk plus Fm plus Fb. So adding up all these forces, what do we get? M into d square x by dt square, m into d square x by dt square, plus b into dx by dt plus k into x is equal to y of t. So taking Laplace transform, what do you get? M into s square x of s plus b into dx by dt, Laplace transform is s into x of s plus k into x of s is equal to y of s. Okay. Then, so taking x of s common, what do we get? Taking x of s common in this, x of s into ms square plus bs plus k equal to y of s. The next step, taking y of s by, or x of s by y of s, if we write, we get 1 by ms square plus bs plus k. Okay. So this is how we write, how we find transfer function for a given translational mechanical system, mechanical translational system. Okay. Here we have just taken, identified the three elements, mass, dashpot and spring. Then drawing the free body diagram. This is a free body diagram where this is a free body diagram. This is a mass element. What is the displacement caused by this mass element? X. Okay. So M, opposing force of this mass element is given by M into A, that is M into d square x by dt square. Similarly for dashpot it is B into V, and for spring it is K into X. Okay. So finally F is equal to Fk plus Fm plus B, as Fm plus Fb. So writing these equations, adding up all these forces, M into A, M into d square x by dt square plus all this. So equal to, the output is nothing but a displacement in that particular direction. Okay. So m into s square, taking Laplace transform using the formulas mentioned earlier, taking Laplace transform of this equation and then rearranging the terms to get y of s by x of s. Then that itself gives you the transfer function. Okay. So only thing is here we mechanical translation system will be having three basic elements: mass, dashpot and spring. Okay. And the corresponding coefficients are for Fm you write mass into acceleration. For dashpot it is B into V, where B is nothing but called as frictional coefficient, and in case of spring it is called as coefficient spring constant, or simply it is called as spring constant or It is also called as stiffness of the spring. So this is about mathematical modeling of mechanical translation system. Next, we'll discuss about rotational system in the next class. Okay.
Like, share and subscribe. Hit the bell icon for more updates.